today's class, I will be teaching you one more useful sequence, step sequences. Step sequences. Category A, positive time unit step sequence. Positive time unit step sequence given by x of n equals u of n. Recall, a to the power n into u of n has a z transform z by z minus a. ROC mod z greater than mod e. Letting a equal to 1, we get 1 to the power n into u of n, which is nothing but u of n, has a z transform z divided by z minus 1. ROC mod z greater than 1. Second one, negative time unit step sequence. Negative time unit step sequence. This is given by x of n equals minus of u of minus n minus 1. Recall, minus a to the power n u of minus n minus 1 has a z transform z divided by z minus 1. ROC mod z less than mod a. Letting a equal to 1, we get. Letting a equal to 1, we get 1 to the power n is 1 only, minus of u of minus n minus 1 has a z transform. Sorry, this is z by z minus a. Sorry, this is z by z minus a. Letting a equal to 1, we get z by z minus 1. ROC mod z less than 1. These are the two corollaries of the previous previous signal. So you should remember this, then put a equal to 1. Remember this expression, put a equal to 1, you get the required answer. Now using these answers, we do few problems now. First problem. First problem. Find Z transforms of the sequences given below. First one, x of n equals u of n minus 2. Second one, x of n equals u of minus n. Solution. Recall u of n, just now we did, has a z transform z by z minus 1. ROC is mod z greater than 1. Then x of n equal to u of n minus 2 will have a z transform. N is replaced by n minus 2. Therefore, this z transform will get multiplied by z to the power minus 2. That is time shift property. Or I can teach you in a slightly different way. Please see. Recall one. I'll make it simpler for you. Recall, x1 of n equal to u of n has a z transform. x1 of z equals z by z minus 1. ROC mod z greater than 1. Applying time shift property. We get. What is x of n? X of n is u of n minus 2. In terms of x1 of n is u of n. So what is x1 of n minus 2? u of n minus 2. So x of n is nothing but x1 of n minus 2. As a z transform, x of z is equal to, because of time shift property, z to the power minus 2 into x1 of z. If you replace n by n minus 2, x1 of z gets multiplied by z to the power minus 2, that is time shift property, equals z to the power minus 2. And what is x1 of z? x1 of z is z by z minus 1. So no change in ROC. No change in ROC. That means ROC is mod z greater than 1. So first you have to remember what is the transform of u of n. Then you have to remember time shift property to get the final result. This is the solution of first problem. Then I'll go to second problem. Again, recall x1 of n equal to u of n has a z transform x1 of z equal to z by z minus 1. ROC mod z greater than 1. We are asked to find what is z transform of u of minus n. Therefore, we have to apply time reversal property. Applying time reversal property, we get. What is x of n? X of n is nothing but x1 of minus n. x1 of n is u of n. So what is x1 of minus n? U of minus n. As a z transform, x of z is equal to, if you replace n by minus n, z gets replaced by z to the power minus 1. x1 of z to the power minus 1 equal to z replaced by z to the power minus 1. Z to the power minus 1 divided by z to the power minus 1 minus 1. In ROC also replace z by z to the power minus 1. Z to the power minus 1 magnitude greater than 1. Or this is modulus of 1 by z greater than 1. Take reciprocals on both sides. When you take reciprocals, this greater than becomes less than, mod z less than 1. This is how this problem is solved. Next problem. Find z transforms of the sequences given below. First one, x of n equals n into u of n. Second one, x of n equals 2 to the power n into u of n minus 3 to the power n u of minus n minus 1. Ask the examination. Solution. First problem will do. Recall x1 of n equal to u of n has a z transform. x1 of z is equal to z by z minus 1. ROC mod z greater than 1. U of n is multiplied by n. Therefore, applying multiplication by n property. Applying multiplication by n property, we get. What is x of n? X of n is equal to n into x1 of n. U of n is nothing but x1 of n. x1 of n has a z transform. X of z. What is the equivalent of n? I told you equivalent of n is minus z into d by dz. Therefore, x of z is minus z into d by dz operating on x1 of z. I repeat, if you multiply u of n by n, this gets differentiated with respect to z and gets multiplied by minus z. This is called applying multiplication by n property. Minus z into d by dz operating on z by z minus 1. If you differentiate this, This is the result. Z by Z minus 1 whole square. No change in ROC. ROC is mod Z greater than 1. ROC is mod Z greater than 1. I'll go to second problem. Second one, solution. Recall a to the power n into u of n has a z transform z by z minus a. What is the ROC? ROC is mod z greater than mod a. Hence, I call this as x1 of n. x1 of n equals 2 to the power n into u of n has a z transform. x1 of z is equal to z by z minus 2. ROC mod z greater than 2. Recall minus a to the power n u of minus n minus 1 has a z transform z by z minus a only, but ROC is mod z less than mod a. Here what is a? Here a is 3. Therefore x2 of n equals minus 3 to the power n u of minus n minus 1 will have a z transform. x2 of z is equal to z by z minus 3. ROC mod z less than 3. In fact, x of n is x1 of n plus x2 of n. Therefore, I'll apply now linearity property. Applying LP means linearity property, we get. What is x of n? X of n equals x1 of n plus x2 of n. Has z transform. X of z is equal to x1 of z plus x2 of z. What is x1 of z? x1 of z is z by z minus 2. x2 of z is z by z minus 3. What is the ROC? Intersection of the two ROCs. That means mod z greater than 2 intersected with mod z less than 3. Mod z should be more than 2 and less than 3. This means mod z greater than 2 less than 3. This is how we apply linearity property to find z transform of this sequence. One more problem if you want we can add here, that is third one. x of n equals 3 to the power n into u of n minus 2 to the power n u of minus n minus 1. I will do that now. One more I have added in the statement. This is the third one. Recall, please watch, recall, a to the power n into u of n has a z transform z by z minus a. ROC mod z greater than mod a. Hence, x1 of n equals 3 to the power n into u of n has a z transform. x1 of z equal to z by z minus 3. ROC mod z greater than 3. Recall minus a to the power n u of minus n minus 1 has a z transform z by z minus a. ROC mod z less than mod a. Hence x2 of n equals minus 2 to the power n into u of minus n minus 1 has a z transform. x2 of z is equal to z by z minus 2. ROC mod z greater than less than 2. Here x of z does not exist. Why does not exist? Because mod z greater than, because the ROC of x of z is mod z greater than 3 intersecting with mod z less than 2 is a null set. Mod z greater than 3, mod z less than 2 concurrently cannot exist. That means individually these two functions have got z transforms, but when combined z transform phase doesn't exist rather, because intersection of the two ROCs is a null set. So please don't get the impression for all sequences Z transform exists. This problem makes stand very clear. When the two ROCs are intersected, if you get a null set, nothing, then Z transform does not exist. Thank you.